Alright guys, in this video we're going to learn how to apply trigonometric ratios to right triangles. And we're going to only focus on how to set up each ratio. So when I say trigonometric, there's a vocabulary word that pertains to the actual study or the actual concept of what we're doing. Trigonometry is the study of the relationships involving the lengths and angles of a triangle. Okay, so when we talk about the trigonometric ratios, we're talking about how the lengths of the sides of a triangle relate to the angles inside of it. Okay, so the first thing we need to do is, there's an error here. We have to change all the A's and C's in these trigonometric functions and make them into D, M, D, M, D, M. I made a mistake by including a diagram that did not even involve an A and a C, so that's why we had to change those up. So you see three words, sine, cosine, tangent, all shortened and abbreviated. These are all three functions, the three trigonometric functions that we're focusing on. So there's a phrase or a saying that you need to remember so that helps you understand or helps you organize the length of the sides based on or depending on the trig ratio that you're dealing with. Okay, and that's so, ka, toa. Alright? How that helps us, it helps us relate a ratio to a specific trig function. So for so, we're using the sine function, and the ratio would be the opposite over hypotenuse. I'll talk about these in a second. For ka, it's cosine, and that's the adjacent over hypotenuse, and tangent would be opposite over adjacent side. So to write these ratios, let's first focus on the top, where we're looking at angle D, and we're going to use the three trig functions to write our relationships to find what the sine, that is the bell, the function of sine of D, cosine of D, and tangent of D. We're not multiplying a tangent in D, cosine in D, and sine of D. It's basically the trig function and letting us know what angle is our reference angle, where we're looking from. So speaking of looking from, when you're trying to figure out the sine, cosine, or tangent of a specific angle, the first thing you want to do in your diagram is draw an eyeball from that angle. So then my eyeball is at D looking at the triangle. Okay, so then when you have SOHCAHTOA, you have the opposite side, hypotenuse, adjacent side, the three different sides of a triangle, depending on which angle you're looking from. Now the hypotenuse is always across from the right angle, so that's the first angle the first side I'm going to draw. So that's my hypotenuse. Now the opposite side and the adjacent side is all dependent on from what angle you're looking from. So if I look from my eyeball and I look across from that specific angle, the side across from that's considered the opposite side. And then the side next to it would be the adjacent side. So then if I'm trying to find the sine of D using SOHCAHTOA, sine of D is equal to the opposite over hypotenuse side. So then the sine of D is the opposite side, BM, over the hypotenuse side, DM. So for cosine of D, still looking from angle D, the ratio we're looking at is adjacent over hypotenuse. So the adjacent side from angle D is DB, and that's going to be over the hypotenuse, DM. And finally for tangent of D, that's the opposite side over adjacent. So again, looking from angle D, tangent is opposite side over adjacent side, so BM over DB. Alright, now let's set up our ratios looking from angle M. So we're going to find sine of M, cosine of M, and tangent of M. Now since we're trying to figure out the trig functions of this specific angle based on these three different trig functions, we have to draw an eyeball at angle M. Now where eyeball is looking at the triangle, and to establish our sides, we always know that the hypotenuse is always across from the right angle, so that will be DM. And now since we're looking from angle M, the side across from it is our opposite side. It used to be over here, but because our reference angle is angle M, the side opposite of angle M is DB. And now the adjacent side, which is right next to it, is BM. So the sine of M is equal to the opposite over hypotenuse side. So then dB over BM. The cosine of M is the adjacent side over the hypotenuse. So from angle M, the adjacent side is BM. And that's over the hypotenuse, which is dm. And then finally, tangent of M. The tangent of M is equal to the opposite side over the adjacent side. So then the opposite side is dB. Whoop. Whoa, going way too fast. Sorry guys, hold on. Alright. So then the tangent of M, is the opposite side, which is going to be dB. And that's over our adjacent side, which is right here, and that's going to be BM.